Long before written history, humans looked up. The stars were predictable, unlike weather, animals, or enemies. This regularity was the first clue. Early hunter-gatherers noticed that certain stars always appeared in the same pattern at specific times of the year. They used these patterns as a calendar. When a certain constellation appeared at dusk, it was time to plant crops. When another set vanished, winter was coming. The sky became a tool for survival. But the sky also held mysteries. A sudden bright star that appeared and faded. A streak of light that vanished in seconds. These were omens, messages from gods or spirits. The predictable stars gave order, the unpredictable ones demanded explanation. This tension between order and mystery drove early astronomy. People began to map the sky, naming constellations and tracking their movements. The first astronomers were not scientists. They were storytellers, priests, and farmers who saw meaning in the stars. The same season. This knowledge helped them track time and direction. Archaeological evidence includes a 32,000-year-old ivory tablet from Germany with carved star-like patterns, possibly a lunar calendar. But the leap from observation to organized astronomy required a new kind of thinking. It demanded writing, mathematics, and a social structure that could support full-time sky watchers. The first civilization to achieve this was ancient Sumer in Mesopotamia. Around 35, Sumerian priests recorded the movements of the moon and planets on clay tablets. They identified 5 visible planets, Mercury, Venus, Mars, Jupiter, and Saturn, and associated them with their gods. Their base 60 number system gave us the 360-degree circle and the 60-minute hour. These astronomical records were not just for science. They were used to create calendars for agriculture and to predict the best times for planting and harvesting. The Sumerians also believed celestial events were messages from the gods, guiding kings and empires. Navigation took thousands of years. By 1200 BCE, the Phoenicians, master sailors from the eastern Mediterranean, had a secret. They navigated using a star that barely moved, the North Star. But here's the twist: the North Star wasn't always the North Star. Earth wobbles like a spinning top, a 26,000-year cycle called precession. So the star that sits still changes over millennia. When the Egyptians built the pyramids, the North Star was Thuban in the constellation Drake. Today, our North Star is Polaris in Ursa Minor. But in 12,000 years, the celestial pole will point to Vega, a brilliant star in Lyra. So the fixed star is only fixed for a while. This wobble also affects our view of the zodiac. The constellations we associate with astrology have drifted by about one sign over the past 2,000 years. So if you think you're a Leo, you might actually be a... They used wasn't Polaris. Due to Earth's wobble, the celestial pole shifts over centuries. In Phoenician times, the pole star was Kachab in the constellation Ursa Minor. They called it the Phoenician star. They relied on this star for navigation, guiding their ships across the Mediterranean. Kachab was their constant companion in the night sky, a reliable beacon that led them to distant shores and back home again. But the Phoenicians weren't the only ancient mariners to use the stars. The Greeks, for instance, learned much from Phoenician navigators. They adopted and adapted their techniques, and soon Greek ships were also crossing the Mediterranean, guided by the same constellation. This exchange of knowledge wasn't just about navigation. It was a cultural bridge. The Phoenicians, through their trade and travel, spread not only goods but also ideas, including the alphabet, which the Greeks would later adopt and transform into the foundation of Western writing. Used the star's height above the horizon to estimate latitude. This knowledge was passed to the Greeks, who refined it. Meanwhile, in the Pacific, Polynesians were achieving something extraordinary. Without instruments, they navigated thousands of miles across open ocean using only the stars, waves, and bird flight paths. Polynesian wayfinders memorized star paths, called star lines, and used the rising and setting points of specific stars as a celestial compass. They also read ocean swells and cloud formations to detect islands beyond the horizon. This knowledge was passed down orally through generations. The Vikings, too, were master navigators. They used a simple tool called a sunstone to locate the sun even on overcast days. By analyzing the polarization of light, they could determine the sun's position and maintain their course across the North Atlantic. These early celestial techniques laid the foundation for modern navigation. Today, GPS satellites orbit the Earth, but the principles remain the same, using known reference points to determine position. The stars that guided ancient sailors still shine above us, a timeless link to our past. Of miles of open ocean, their method, a star compass, an imaginary circle of the horizon divided into 32 points, each marked by the rising or setting of a specific star or constellation. They memorized the positions of these stars and used them as reference points to navigate at night. During the day, they read the sun's position and the direction of ocean swells. They could feel the motion of the waves through the hull of their canoe, detecting subtle changes that indicated land was near. The color of the water, the flight of seabirds, and the presence of clouds all provided clues. They also used a technique called wave piloting. By memorizing the patterns of swells and how they refracted around islands, navigators could steer toward land even when it was beyond the horizon. This required years of training and an intimate knowledge of the sea. This deep understanding of nature allowed Polynesians to settle the most remote islands on Earth. Their voyages were not random drifts but planned expeditions, carrying people, plants, and animals across vast distances. They turned the Pacific into the order of stars as they rose and set. They also used the zenith star, the star that passes directly overhead at a given island. By knowing which star was overhead at their destination, they could set a course directly. But the most remarkable tool was the star compass, a mental map of the sky divided into 32 houses, each named after a specific star or constellation. The navigator would memorize the rising and setting points of these stars around the horizon, creating a celestial ring that never changed. During the day, when stars were invisible, they relied on the sun's position and the ocean swells. Swells created by distant storms travel in consistent directions, and experienced navigators could feel the motion of their canoe relative to these swells, using their bodies as a living compass. They also observed the flight paths of seabirds. Frigate birds, for example, fly out to sea in the morning to feed and return to land in the evening. A navigator seeing a frigate bird at dawn would know that land lay in the direction from which the bird came, could sail toward it. Evidence comes from oral traditions and modern reenactments by the Polynesian Voyaging Society. The Greeks turned star watching into a science. Around 150 BCE, Hipparchus created the first star catalog, listing over 850 stars and their positions. He also discovered the precession of the equinoxes, a slow wobble in Earth's axis that shifts the stars over centuries. Hipparchus's catalog was a monumental leap. It allowed astronomers to predict celestial events with greater accuracy. But his work was lost for centuries, preserved only through the writings of later scholars like Ptolemy. Ptolemy's own catalog, the Almagest, became the standard for over 1,000 years. Meanwhile, in the Americas, the Maya were building observatories and tracking the movements of Venus with astonishing precision. Their Dresden Codex contains tables predicting Venus's appearances over hundreds of years. They believed Venus was a warrior god, and its cycles dictated times for war and ritual. The Maya also developed a complex calendar system, including the long count, which tracked time over thousands of years. Their observations were so accurate that they calculated the solar year to within minutes of modern measurements. This knowledge was passed down through generations of priest astronomers, who used it to align their cities with the star. 850 stars with coordinates. He also discovered precession, but the real breakthrough came later, the astrolabe. This handheld device allowed sailors to measure a star's altitude above the horizon. The astrolabe was perfected by the Persian astronomer al-Biruni in the 11th century. Al-Biruni's version was more accurate and easier to use. It became the GPS of the medieval world. Navigators could now find their latitude by measuring the North Star. This simple trick opened up the oceans. Ships no longer had to hug the coast. The astrolabe remained the essential tool for centuries. It was the key that unlocked global exploration. Without it, the age of discovery might have stayed in port. Islamic scholars and spread to Europe. By the 15th century, Portuguese explorers used it to sail down the African coast. The astrolabe made latitude measurement practical, but longitude remained a problem for centuries. The astrolabe made latitude measurement practical, but longitude remained a problem for centuries. The solution came from an unlikely source, a clockmaker. The solution came from an unlikely source, a clockmaker. John Harrison, a self-taught carpenter and clockmaker from Yorkshire, dedicated his life to building a clock that could keep accurate time. John Harrison, a self-taught carpenter and clockmaker from Yorkshire, dedicated his life to building a clock that could keep accurate time at sea. His first marine timekeeper, H1, was completed in 1735. The Astrolabe was good, but the Sextant was better. Invented in the 18th century, the Sextant used mirrors to measure angles more accurately. It could also measure the angle between the moon and a star, which helped sailors find their longitude. The Sextant worked by aligning two mirrors. One mirror reflected the horizon, the other reflected the sun or a star. By moving the arm, the navigator could bring the two images together, giving a precise. Unlike the Astrolabe, the Sextant could be used on a moving ship. The mirrors stabilized the image, so even in rough seas, sailors could get a reading. This made navigation far more reliable. The Sextant remained the primary tool for celestial navigation until the 20th century. Even today, it is still used as a backup on ships and aircraft, a testament to its. The chronometer solved the longitude problem, but it was expensive and delicate. Most ships still relied on lunar distances, measuring the angle between the moon and a known star to calculate time at sea. This method required clear skies and careful observation. By the 19th century, celestial navigation was a standard skill for any ship's officer. Every naval academy taught the use of the sextant, the chronometer, and the nautical almanac. A navigator could determine his position within a few miles, even in the middle of the ocean. The sextant remained in use until the late 20th century. Even after the invention of radio navigation and GPS, sailors were taught to use it as a backup. There is something reassuring about a tool that needs no batteries and no. Today, celestial navigation is a niche skill kept alive by hobbyists and traditional sailors. But its legacy is everywhere. Every GPS satellite relies on the same principles of time and geometry that the old navigators used. The stars still guide us, even if we no longer look at them. But the principles, using stars as fixed reference points, were the same as those used by the Phoenicians and Polynesians. Today, GPS satellites have replaced the stars. But the knowledge that ancient people built, observing, memorizing, measuring, is still the foundation of every navigation system we use. The Phoenicians, sailing the Mediterranean around 1200 BCE, relied on the North Star to keep their bearings. They memorized the positions of constellations and passed that knowledge down through generations of sailors. The Polynesians went even further. They developed a complex system of wayfinding using the stars, ocean swells, and bird flight patterns. They could navigate thousands of miles across the open Pacific with no instruments at all. Today, a GPS satellite constellation of 31 satellites orbits Earth, each broadcasting precise timing signals. A receiver on the ground calculates its position by measuring the time delay from at least 4 satellites. The ancient principle of triangulation, using known reference points, lives on in modern technology. With us, every time we look up, we see the same stars that guided a Polynesian voyager, a Phoenician trader, a Greek scholar. The stars are a constant. The story of celestial navigation is a story of human ingenuity, of looking up and finding our way. It begins not with a map, but with a question. How do you find your way across an endless ocean with no landmarks? The answer lies in the sky. Ancient sailors noticed that certain stars always appear in the same part of the sky at a given time of year. By memorizing the rising and setting points of key stars, they could steer a course. The Polynesians, for example, developed a sophisticated system using the rising and setting points of stars, the sun, and the moon, combined with knowledge of ocean swells and bird flight patterns. They could navigate thousands of miles across the Pacific with remarkable accuracy. The story of human curiosity and courage. It reminds us that we are all, in a way, navigating by the light of distant suns. The stars were our first maps, and they still are. Ancient sailors used the North Star to find their way across vast oceans. They knew that if they kept Polaris in sight, they would never lose their bearing. Today, satellites and GPS have replaced the stars, but the principle remains the same. We triangulate our position using signals from above. Whether by starlight or satellite signal, we are all navigating by the light of distant suns. The stars were our first maps, and they still are.